Okay, so today we are moving on with lesson 4.4, which is going to go over how to write the equation of a line in standard form. So, starting out, let's talk about standard form. We've talked about standard form before when we were graphing equations, particularly when we were graphing things using the intercept method. We found that to be the most useful when equations were in standard form. So standard form, just to review, is when you have your x and your y terms both on the same side together of the equal sign, and then on the other side of the equal sign you have your constant term. So we typically will write it as ax plus by equals c. Now there's a couple rules when things are in standard form. The first rule is that a, b, and c must all be integers. And that means that there can be no fractions or decimals in the final answer when it's written in standard form. Now, we know from previous lessons that when equations are in point-slope form or in slope-intercept form, we often see fractions or decimals. But in standard form, we should not see fractions or decimals if it is completely put into the proper standard form. Additionally, your a, which should be the first number that you see because it's the coefficient of the x, will have to be positive. Now the B and the C can be negative. There's no restrictions on that, but the A should be positive. All right, so first let's go over putting some of these things into standard form. So if I take a look at my first example, the first thing that you want to do when you want to put something into standard form is make sure that the x and the y terms are both on the same side of the equal sign and the constant is alone on the opposite side of the equal sign. So in this question, example A, I already have the y on the left and I already have my constant, which is this 2, on the right, but the x is on the wrong side. So I'm going to need to move that over to the left with the y. Now, when we move things from one side of an equation to another, the sign is going to change, and that's because, really, in order to move this, I'm adding it to both sides. So once I've done that, I now have positive 5x plus y on the left-hand side of the equal sign, and then on my right side, I'm just left with that 2. Now, just double check your answer. Once you have the x and the y together on one side and your constant on the other, you want to check and make sure there are no fractions or decimals. You only have integer coefficients, which we do here. We have a 5, a positive 1, and a 2. And make sure that that x coefficient, which is your a term, is positive, which it is. We have a positive 5. So this would be our answer in standard form. I'll come back to B in just a minute. Let's take a look at example C. Okay, so for example C, again, we have the y on the left, the constant on the right, but the x term needs to move over to the other side. So when I subtract that 4x over, I'm left with negative 4x plus y equals negative 7. So we have it set up in the proper format now. However, and there are no fractions or decimals here. However, my a term in this particular example is a negative, which I need to get rid of. So at this point, if you have a negative on your first term, that x coefficient is negative, you want to either multiply or divide everything by that negative 1, and that will effectively change all your signs, which will make that a term now become positive. However, it'll also make my b term switch signs, so that'll become a negative y, and my c term will switch signs as well, so that will become a positive 7. So essentially, if you have to change the sign on the A, you're just going to change the sign throughout the whole equation. Now going to example D. Example D, again, we have the y on the left and the x and the constant on the right. So the first thing I want to do is move my x term over to the left, which will change the sign. So I will have 2/3 x plus y equals 1. Now, in this particular situation, I'm not happy with the fact that there's a fraction here, so I'm going to need to get rid of that fraction. Now, in order to get rid of this fraction, we can multiply by something for it to cancel out. Now, the thing with standard form is you can multiply your equation or divide your equation by anything you want, and it still stays true to standard form. as long as it happens with everything. So my equation will still be equivalent if I multiply this by a 3, as long as I make sure that 3 gets multiplied to everything, the x, the y, and the constant. Now, the reason why I would do this is I don't mind having a number in front of my x like the 2. I just can't have that fraction. So I just need to get rid of the bottom number, which is the 3. So if I multiply by 3, then that will cancel out there. So I would just be left with 2x. But then when I multiply my 3 to the y, I will have 3y. And then when I multiply my 3 to the negative 1, I will have negative 3. Now I'm going to check it. There are no fractions or decimals left in my equation, and my lead coefficient of positive 2 is good because I need that a to be positive. All right, now we take a look at example E. Same setup here. We have to move this x term over to the left. So that will make this negative 1/4 x plus y equals 3. Now in this case, not only do I not like the negative, but I also need to get rid of the fraction. So I have two things this time that I don't really like here that I need to change. So just like in the last problem, if you have a fraction, you can multiply by that denominator, which in this case is 4, and that will cancel out your fraction, and it will keep your other terms integer terms. But not only do I have to get rid of 4, I also have to get rid of this negative. So I could just distribute a negative 4 to everything, and that will take care of both of those in the same step. So when I distribute a negative 4 to negative 1/4, the negatives and the 4's cancel. I'm just left with 1x. When I distribute the negative 4 to the y, I have negative 4y. And when I distribute the negative 4 to my 3, I get negative 12. No fractions anymore, no decimals. My x coefficient is a positive 1. So this is a good standard form answer. Now, if I take a look at example F, the y is already on the one side. I don't have an x term here, but I do have a constant, and the constant needs to be on the opposite side of the variables. So I'm going to move my 6 over, which will effectively give me y equals negative 6. Now, at this point, because I don't have an x term, it's just going to be y equals that constant term. I don't have any fractions or decimals, but even if I did, there wouldn't really be much I could do at this point. But this is just one of those exceptions that my slope-intercept form and my standard form are just going to result in the same equation, because this is an equation of a horizontal line with a slope, with a slope of 0. Okay. All right, so let's go back to that decimal problem that I kind of skipped over in the beginning. All right, so with decimals, there's a couple ways we could go about this. So one option is you could look for the smallest number that would effectively cancel out those decimals. That's one option, and I'll get to that in a minute. But the easiest option is to multiply by some multiple of a 10. So if you have to move your decimal place over in one spot, you can multiply everything by 10. If you had to move a decimal over 2 places, then multiply everything by 100. If you had to move something over 3 places, you can multiply everything by 1,000, and so on. So it's just a quick, easy way. It doesn't take too much, and then it's easy to multiply by 10s and 100s and things like that. So if you look at the first number here, this is 0.5, I would need to move my decimal one place to make it an integer. The 2 I won't really have to worry about, and then this 0.75, I would have to move it 2 places. Now, the thing is, you can't multiply each of these by different numbers. You have to just multiply everything by the same number. So you have to pick the number that will make sure it fixes everything. So we're going to have to multiply this by 100 because we need to get rid of the 0.75, and we'd have to move the decimal over twice to do that one. So we're going to have to go with the 100. So 100 times 0.5 would move that decimal over twice, which would give me 50x. 100 times 2 is just 200. So that becomes minus 200y. And then 100 times 0.75 is going to give me a 75. Now this is in standard form. There's no fractions or decimals. and my lead coefficient is positive 50, so I don't have to worry about a negative there. However, there are other answers I could have gotten for this in standard form as well that would be an equivalent equation to what we have here. So just to show you another example. So if I have 0.5x minus 2y equals 0.75, I'm pretty sure I probably could get an equation with smaller numbers than 50, 275, because if you'll notice, all of these are divisible by 25. Okay, they're all divisible by 25. So if you do it this way and you multiply by the 100 or the 10 or the 1000 or some multiple of 10, you might notice, okay, that when you do that, you could maybe simplify. Again, like I said to you before, it still holds true to standard form if you multiply all the numbers by something or you divide them all by something. So since all of these are divisible by 25, I could actually simplify this just by dividing them all to make the number smaller. And the reason why you might want to do that is if you had to graph it or something like that. So 50 divided by 25 would be 2, so this would be 2x. 200 divided by 25 would be 8, and 75 divided by 25 would be 3. So this here is another standard form equation that is equivalent to the original one that we got. Now, let's say you don't want to have to get something with really big numbers and then try to make them smaller. So another option here would be to just kind of from the beginning figure out, well, what number could I multiply all these by to get rid of the decimals, but maybe not give me such quite large numbers, right? So if I really know that this is a 1/2 x here, and then this one here is really 3/4, I might say, well, what do 2 and 4 go into evenly? They both go into 4. So if you distributed a 4 to this from the beginning, you would have ended up with this answer here, because 4 times 1/2 or 0.5 would give you that 2x, 4 times 2 would give you the 8, and 4 times 0.75 would give you 3. So a couple different ways you can kind of work with those decimals. So like I said, the quickest, easiest, straightforward way to do it is multiply by 10 or 100 or 1000 or whatever you need to move your decimal place over. But if the numbers that gives you are too big for you because maybe you have to graph or something, then you can always divide everything by a common factor to make them smaller. Or if you're just kind of good at recognizing what maybe will get rid of those decimals or cancel out those fractions right from the beginning, that's an option too. So you got a little bit of options to play with for the decimal ones. All right, so let's work with this now. So if we want to write an equation in standard form, and we're just given a little bit of information from our line, okay? So the general steps that we're going to go through to do this are as follows. So the first thing that we're usually going to do is make sure we know what the slope is. So we're going to find that slope. Now, in these particular problems that we're going to start with, it's already given to us, but sometimes we're going to have to go out of our way and find it. Maybe use rise over run or the slope formula, something like that. Now, the second thing we want to do after that is we have two options. One option is that we can find the y-intercept, which is that b value, and we can use the y equals mx plus b equation to do that if we're given a point. Or the other option is we can use point slope form. Okay, and this is point slope form. And it's really a personal preference which of these you prefer to do. I typically prefer to use point slope because I feel like it kind of flows nicer. But if you have a preference of finding the b instead, then you can. Because the whole point is, regardless of which of these methods we use, our goal at that point is to get our equation into slope-intercept form, which you can do from either of those methods. Okay, then finally, once you get it into slope-intercept form, you're going to get that x and y on the same side and make sure you can get your answer into that standard form. Okay. All right, so like I said, the first step for all three of these equations has been done for us because we are just being given our slope for these. We don't have to use slope formula or calculate it or anything like that. So we're going to go into step 2. So before we can get it into standard form or even slope-intercept form, we either need the y-intercept or we can put it into point slope and then kind of convert it over. So I'll do one problem each way and then you can kind of decide which way you like better. So for example A, I'm going to use the point slope method here. So using this point as my x1 and my y1, and of course my slope is my m, I'm going to do y minus 5 equals -3 times x minus 2. So I've just completed step 2. But now I have to get my slope-intercept equation. And I'm going to do that just by getting rid of my parentheses. So -3x plus 6. And then I'm just going to add my 5 over to the other side. And that's going to get me y equals -3x plus 11. And that would be my slope-intercept form. So now finally, I can get my answer in standard form. So to do that, I'm just going to take this x term and move it over to the other side. Of course, that's going to make it a positive 3x plus y equals 11. I'm checking for fractions and decimals. I don't have any, and my lead term is a positive 3. So I know that I'm finished, and that is my answer in standard form. Okay, so now for the next equation, we already have the slope for us, so we don't have to worry about that first step. But this time, instead of using slope-intercept, I'm just going to find the y-intercept, which is the b. So that means I'm going to have to actually use y equals mx plus b. So this is my x and my y. So I would substitute in my -8 for y, my 1/3 for the slope, my 6 for the x. I would simplify this. So 1/3 of 6 is 2. Get the b by itself. So that gives me a b value equal to 10. So now, in order to get my slope-intercept equation, I just write y equals, I use the slope that I have, and then the y-intercept that I just figured out, which was 10, and I have 1/3 x plus 10. If you did point slope, you'd end up at the same spot at this point. So now we're going to get this into standard form. So we're going to move this x term to the other side. So that's going to make it -1/3 x plus y equals 10. And of course, I have to get rid of my fractions when I have to multiply by 3. But I also need to get rid of that negative. So I'm just going to distribute -3 to everything. That's going to give me positive 1x minus 3y equals -30 as my answer in standard form. Okay, so again, it's personal choice whether you want to use that point slope form or find the b and then put it in slope-intercept and go from there. All right, so let's take a look at example C. So for this one, I personally prefer point slope, so I'm going to use that one. So when I do y minus my -7 equals 4 times x minus 6. Now when I go to distribute here, I'm going to have 4x minus 24. And I know that when I subtract a negative, that's really an addition sign. And then I'm just going to move by 7 over. So I have y equals 4x minus 31 as my equation in slope-intercept form. So now I just need to move my x term to the other side. So this 4x is going to go over here on the left, which will make it a -4x plus y equals -31. And then I just need to get rid of the negative. I don't have to worry about the 4. So when I do that, that's going to change my -4x to a positive 4x. My y will become a negative y, and my 31 will become positive 31. Okay, so let's try a couple more. Okay, so if we take a look at example D, again, the slopes are still given to us here, so I don't really have to do too much for that first step of finding the slope. It's already done. Okay, so now for this one, again, point slope, y minus 4 equals negative 1/6 times x minus negative 2 will become an addition sign. Now I'm going to distribute my 1/6, or my negative 1/6, I should say, and that's going to get me a negative 1/3 when I multiply it by 2. So now this is the piece where I have to add a fraction. I have to add negative 1/3 plus 4. Now this is where I'm recommending a lot of you guys use the calculator. So if you have a negative 1/3, don't be afraid to pop it in your graphing calculator, add the 4 to it, and remember to change that decimal to a fraction, math, enter, enter on your graphing calculator, which is 11/3. Of course, you can definitely just do it the old school way by adding your fractions, negative 1/3 plus 4/1, getting your common denominator, and so on. Okay, now we have to put this in our standard form. So I'm going to move my 1/6 over to the other side, which will make it a positive 1/6 x plus y equals 11/3. Okay, so now I need to get rid of these fractions, but I have two different fractions. So do I multiply everything by 3 or do I multiply everything by 6? Well, think about it. 3 and 6 both need to cancel. So 3 and 6 will both go into what? They'll both go into 6. So that's what we need to distribute, a 6. When I distribute my 6 to 1/6, obviously they cancel. I'm just left with x. 6 times y is going to be 6y, and then 6 times 11/3. Those can reduce, and then 2 times 11 is 22. Even if you multiplied it out, you would have had 66/3, which would simplify to 22. All right. Now the next problem, we have E here. This one, if I do y minus 6 equals 0 times x minus negative 7, which is a plus, notice that the 0 is multiplying everything on this side, so that's all going to cancel out, and I'm really just left with a 0. And so now when I go to put this in slope-intercept form, I end up with just y equals 6, which again is an example of an equation of just a horizontal line, because that slope will cancel out that x component, and then you just have y equals that number 6. Okay, our last example here, y minus 3 equals negative 3/4 times x minus negative 4, which will make it a plus 4. Putting it into slope-intercept form, I'm going to distribute. So I have negative 3/4 x, and then minus, and those 4's will cancel, so I just have a minus 3. Now when I go to add my 3, notice that I end up with y equals negative 3/4 x plus nothing, because it just so happens that they cancel out on that side as well. So when I go to do my standard form, and I want to move this over to the other side here, just be careful, because when you move that over, 3/4 x plus y, you might be like, well, wait, what's on the other side? There's nothing there, so you have to put in that 0. And then, of course, you would distribute the 4 to get rid of that fraction. Make sure you distribute it to everything. And you end up with 3x plus 4y equals 0. Okay, so now the next few problems here is going to be the same idea, but now the slope's not given to us. We're actually going to have to use that slope formula to find the slope. So here for step 1, I'm just going to do my y2 minus my y1. So for me, that's 3 minus 5, and then my x2 minus my x1. Negative 2/1, so that means my slope is negative 2. Now you either can find the b or use point slope. However, in this problem, it just so happens that one of the points that was given to us already was the y-intercept. So for me, it's just easier to say, oh, the b is 5. I don't really need to do point slope there. If you did, you'd end up in the same place anyway. Y equals negative 2x plus 5. So no harm, no foul. All right, now we just want to get this into standard form. So I move that 2x over, making it plus 2x, or positive 2x plus y equals 5. And then there are no fractions or decimals, and my lead coefficient is positive, so I know that I'm done with that answer. All right, if we take a look at example B, slope equals 1 minus negative 3, and then 4 minus negative 2. I did y2 minus y1. Now, when we subtract a negative, we know that changes to addition. So this is really 4/6, which is going to simplify to 2/3. Now I'm going to use my y minus y1, but I have a choice of points. I probably will choose the 4 and the 1 because they're positive. So y minus 1 equals 2/3 x minus 4. If you did it the other way, you'd have y plus 3, and then 2/3, and then x plus 2. Either way, when you distribute this 2/3, and then you bring this number over, in my case it's a 1, you should end up with the same slope-intercept form. So for me, I have y equals 2/3 x, and if I do this on my calculator, negative 8/3 plus 1. So I have negative 8 divided by 3. That's my negative 8/3 plus 1. That's my decimal answer. Math, enter, enter, gives me my fraction of negative 5/3. So now to put this in standard form, I want to bring my x term over to the other side. This will make it negative 2/3 x plus y equals negative 5/3. Of course, I don't like the negatives or those 3's there on the bottom, so I'm going to distribute negative 3 to everything, which will then give me positive 2x minus 3y. Make sure you distribute to the y, even though there's nothing to get rid of, and then positive 5. That is my answer in standard form. All right, now this next example, finding our slope. Slope equals negative 3 minus 3 on the top and negative 5 minus 1 on the bottom. That gives me negative 6 over negative 6, which of course simplifies to a slope of 1. So y minus, I'm going to use this point here, y minus 3 equals 1 times x minus 1. If you distribute a 1, nothing is really going to change. It's just going to be y minus 3 equals x minus 1. And then we will add that 3 over, so I get y equals x plus 2. To get it into standard form, I need to move my x term over, making it a negative x plus y equals 2. And then I have to multiply by the negative 1, which will give me positive x minus y equals negative 2 as my answer in standard form. Okay, now there's 3 more examples, similar idea. I'm just going to go to do number or letter E because it's a little bit different. So if I go to find my slope here, look what happens. 2 minus negative 6, and then 4 minus 4. So on the top, we subtract a negative, so it's addition, we get 8. But on the bottom, I get 0. So this slope is, if you remember, it's called undefined. Okay, so whenever you have a slope that's undefined, remember when the 0 is underneath, it's undefined, that means that this would be a vertical line. And the equations of vertical lines are just x equals a number. Well, look over here. What are both of the x values? This tells us if 2 points on the line both have the same x value, it has to be a vertical line. That means all the points would have to have an x value of 4. So the equation of that vertical line would be x equals 4. Okay, so with that being said, let's write an equation in standard form of the horizontal and vertical lines that would pass through this one point. So what does that look like? So let's say we have a coordinate plane, right? And then we have the point 1, 3. So over 1, up 3. So this point. So we want to know what is the equation of this line, this horizontal line, and this vertical line. So there's two separate equations here. Now, we just talked about vertical lines. They always have the equation x equals a number. Well, what is that x value on all of the points on this line? They all are going to have this x value of 1. So the vertical line is going to have to be x equals 1. And then the horizontal line, if this is a 3, all the other points on that line also are going to have a y value of 3. So your horizontal line's equation would be y equals 3. So we don't really need to draw this because we had that point given to us, and it was saying the horizontal line going through that point and the vertical line going through that point. So a horizontal line going through this point here, if the point is negative 3, 7, it's going through the y value of 7. And the vertical line would be going through the x value of negative 3. All right, and then to finish up, just a lot of times we have word problems where standard form is the best way to represent the information involved. So typically this happens when you have two separate things that are going to be combined and to give you a total. Now, pretty much every time you go to the store and buy something, or you buy like more than one thing, this is occurring. So in this example, if you go to Old Navy, let's say, and you're going to buy some shirts and you're going to buy some pants, but all the shirts are one price and all the pants are another price, and you have a set amount to spend, or a set amount or you know the total or something like that, then you're going to be using the standard form. Because think about it, you go up to the cash register, right? If you bought like 5 shirts, but they were all like the same price, you would be like, the register would scan maybe a shirt and it's just going to multiply it by how many you got. So let's say you got 5, it'd be like, oh, $14 times 5, right? Then the pants or whatever else you're buying, let's say they're all $35 and you just bought a bunch of different colors or styles or whatever. Then you have $35 and that's going to be multiplied by however many pairs you bought. And then, of course, that's the total of $140 that they're giving you. Now, if it's, it says you have up to 140, so technically this would be an inequality here. It would be less than or equal to 140 because you don't have to spend all your money. But we're not really getting into inequalities right now until maybe next week, so I'm not going to focus on that just yet. But this is how you would set that up. So then you could basically figure out if you had, let's say 5 shirts, how many pairs of pants could you buy, or vice versa. So looking at the next question, which is a little outdated, as you can see, because we're not really into CDs too much anymore, but we're at a music store. The store was selling CDs for 2 different prices. So maybe there was some on sale for 14, and then you have the full price of 18. If you don't want to think about CDs, you could think about any 2 things that you would be possibly buying for those amounts of money. So again, you would have 14 times X, which however many you're going to buy at that purchase at that price, plus 18 times Y, because $18 will get multiplied by however many are purchased at that price. And then the total would be the $90 that you had to spend. And then, of course, if you're given one of those variables, then you can easily solve for the remaining one.